Let me quickly run you through the process I used to 3D model a representation of this Fortnite Scarlett Solo audio interface. The way I will do this is I will go and basically talk about every element I did, but rather by actually using the timeline and then step by step going forward. Okay, so we will start obviously with a sketch from the front. The scene is in millimeters, and there you can see the dimensions. 145 for the width, 41 millimeters for the height. There's a small construction line at the center to center the rectangle at the midpoint, and the dimension is 2.25 millimeters. This way, then I can create a cube, an extrusion going 82 millimeters symmetrical for the whole distance. So 82 millimeters whole, 50-50 forward and backwards. Then I can round these edges by 5 millimeters. Simple G1 is fine. And now we will select the two front and back faces and then shell it by 2.25 millimeters. So now I have actually an extruded aluminum casing, and I can start constructing the next element. So I will start with the back panel. Sorry, no, actually I will start with the ground first. Okay, good. So in this ground sketch, you can see if I hide the body and I go to this view, there you can see all the values here I have that I projected in via the project command. This edge and this edge, because then this is the left and right side, and I have the height, and then I drew in the missing two lines. Here's a ring, diameter 15 millimeters. From the center to here, and it's 20 millimeters, and from the center of the ring to this edge, it's 14 millimeters. Now later we have to make actually 4 pieces, so 3 copies. And I don't want to copy and move them by hand, so we will use actually the pattern tool for that. And to know how and where I have to move everything through the pattern tool, in the sketch already, I put down 3 more points. So here's a point, click, click. And then to figure out the dimensions, see here I drew myself some lines. These lines I turned into a construction line, very good. And then via horizontal and vertical constraints, I aligned everything a little bit. Super easy. Some more dimensions. So for example, the dimension from this point to here is this dimensions. So you see when I click on this, it copies that value in. Okay. And then the same here, the dimension from this point to this edge is 14 millimeters. Or double click, click this dimension, and there we are. Now, by having then these 2 points vertically aligned, here they are aligned, and they're horizontal, I can then measure out myself, when I press D, the dimension or the distance between these 2 points. So 105 and 54 millimeters. Very useful. Okay, because now I can start thinking, how can I build this block? So there we are. You see, I moved this one up by 2.25 exactly to the height where the extrude aluminum body starts. I could also go ahead and say to object, and I select this face, pretty much the same. And why did I make a cylinder? Well, the cylinder I can use to create then a construction line through it, like an axis. So create axis through this cone. You see, super easy. Why did I make this cone? Well, that cone is very useful because then I can use plane at an angle, select this axis, and then I can create a construction plane on it. And on that construction plane, then we can create another, you guessed it, sketch. Very good. So you see here two lines. These two lines are actually intersected lines from this face and this face. I could, if I wanted to, also only had used the top and the bottom of the cylinder. The reason why this is very useful is, like with here, this is the width of the cylinder, so we have a midpoint. And then to draw everything, so here from the midpoint, I started drawing a line up till it hits, draw from there a line over, then a line down, 0.5 millimeters, and then from there we simply patch in an arc. And then I move this arc till on the right side, you see it says it is tangent. Yeah, and that's it. And you see these two lines I found via intersection, they are selected and then turned into a construction line. Okay, then now you see I have a sketch profile. I can then rotate it. I moved the lines, or rebuilt the lines, so the axis was missing. There we are. Okay. Very good. Yeah. So then this initial cylinder served its function. We can delete it via the remove command. Here is now the pattern command. So I'm going to go back to sketch 2. Hold on. So we show sketch 2. Right click and say show dimension. Thank you. There we are. So you see when I create a pattern, I have these two arcs. I can then read out the distance, and then this is all put in there. So the way how this works, here, let me go back to this position. We go pattern, rectangular, body, this body, direction, I don't know, maybe this way, and I can push this one out, push this one down. Now then we need to adjust the count. And then this will be exactly minus 105. And then this will be 54. Okay, and then this way the feed will exactly fit into place. So one way how to use this pattern command. Good. So now we have that done. We can work on the back part. So here is the image I took of the Focusrite, the audio interface from the back, just so you understand roughly how it looks. And we would like to have the back face not flush to here, but a little bit to the inside. So to do this, I will use a construction plane and then bring this one in by the specified dimension. And then where this construction plane is, then I can create a sketch and intersect with the geometry. So here's my construction plane. You can see I only brought this in just 0.5 millimeter. Maybe so it's easier to see, let's say here 1 millimeter. Okay. And then on this construction plane, we create a sketch. There we are. And to find all these edges, we go create, intersect, and then we select all these interior faces. No, not the exterior, because that doesn't make sense. We're working on the interior. Here I will, just for the sake of demonstration, select the outside, and there you can see there are the lines. When I click OK, these curves are now projected into there. Very good. Okay, now let me delete this. And then this way we actually can create as a profile which we could extrude, and then it would perfectly fit into the interior of our extruded aluminum body. Now we also have these interface elements, the line outputs, and also here for the USB-C. You can see how I created this, a very simple rectangle, and then I added some dimensions to it. The circles, the way how I did this little trick, we make the circles the same, so equal. Then we align them. Then we can give them a radius. Very good. And now if I would like this ring have a distance to the top of 4 millimeter, now I can go to dimension, right click, say tangent, and this is the important thing. So tangently make me a dimension 3 millimeters, and then right click, because it switches back to stupid center, there to here, maybe by 50. Yeah. And then also the distance between them, again, tangent, so right click with the mouse, 10. Yeah. So that's the way how this works, because they have a horizontal constraint. If I change this one to 5, you see they move together because the rings are set to equal. If I set this to 5, they scale equally. Just some very simple, or not simple, effective shortcuts. Then let's finish the sketch. And then it's time to actually extrude it. Also here, very simple, we just go to extrude, select this profile, excluding the openings. We extrude it 1 millimeter as in your body. And then we can go in and round these inner corners. So you see also here, I did not do this in the sketch. I'm going to solve this via 3D modeling. That is simply much, much better. So what we did in the back, then we can also do simply in the front. So I made a new construction plane. Same deal, just a millimeter to the inside. And then I added my canvas image here for the front part. I also scaled it so it's roughly to scale. This is a perspective photo, so we cannot use this to really sample dimensions from it, but it helps us to understand if our sketch is somewhat correct. Here's then the sketch. This is already a little bit more dense, but primarily it follows exactly the same process. So let me hide all the elements we don't really need to see. There we are. We go into the sketch. So I found these lines too by intersecting the sketch with the inside faces of, in this case here, body 1. Create, intersect there. And yeah, where do we start? Let's maybe go to here. This is maybe a little bit easier. And I'm just moving everything around there. So we can see here, this is this ring. It's vertically aligned to this ring. Then it has a tangent dimension of 8 and 7. This ring has actually an equal constraint here to this. Maybe we take this one out and put this rather to here. So this is more grouped, so 9 millimeters. This ring also has a horizontal constraint to this ring. Okay, so they're the same. Very good. This ring here on top has 6 millimeters diameter, 7 millimeters to this edge, and then to the side I don't have anything because it is vertically aligned. The next ring here, 23 millimeters, and what's actually this one? 7. Oh, so where's the 7 actually coming from? Oh, it's actually, is it from those? Yeah. So this ring has the same dimension as those. It's an equal. And I will go to this at one point, but this equal constraint you can add later. Yeah. Good. There's also, as you can see, a dimension here that specifies from here to here. Again, D, right click, tangent, dimension, and then this is horizontally centered to there. Cool. Then let's go to here. 2 rings, they're inside here too. There's actually, you see a dimension for the inside. So DU to U, 3 millimeters. Okay. The outside is, where do we have actually a dimension for that? Oh, it's here. There it is, 13. 3 millimeters from the top tangent. And also here, the 2 elements are horizontally constrained, and then the inner and the outer ring are equally constrained. And we have a distance of 22 between them and a distance of 34 from the left to the right. So you see the commands are pretty much the same. They repeat each self a lot. There's just a lot of arctangent. Okay, now what's going on actually down here? So these 2 rings needed to be perfectly centered under here, and then this ring needed to be perfectly centered between these 2 rings. And to achieve that, let me delete this. It was actually super simple. So from here to here, a line, okay, and then I select the line, and with X, or here the construction option, we turn this into a construction. And then U to U, there we can do the same. This line is to be set vertical, and also construction line. Okay. Now, and then what's the distance? I think I was 5. Yeah. Let me just undo the steps. Actually, no, I did not set a dimension because this ring to here, they are actually horizontally already. Okay, good. Because when you design an interface, that is what's really interesting about this exercise is you don't want these buttons to float really crazy around, and you would like also for yourself to have some sort of a means to move things around evenly. So when I move this right ring up, you see this ring here, which should be horizontally aligned, follows with it. So all these constraints are just geometrical rules we established. And then here, these 2 rings, we drew a line and a line. The line is horizontal, line is horizontal. And then to make them left and right centered to here, just a vertical line. And that line is centered. There's no distance for this line because that's actually given by this. So we have here the right click arctangent dimension of 4 millimeters. Okay. And then we have here the last one, a big circle and a smaller circle, and then an even smaller circle and 3 circles there. There are a lot of dimensions floating around here. Let me move these around. So 16, 22, and 8.5. And then the smaller ones are 2.5. I created this ring that is dashed, and then I created on a dashed ring these smaller rings, these 3. And then to make them horizontally or vertically centered, You see, vertical or horizontal constraint. If this one should be a horizontal, and then I need to create this one closer to here and not more on top, because the software will switch between horizontal or vertical based on is an object more vertical or more horizontal. Okay, now and then I dimensioned this one ring, very easy. And then these other two, they got the equal constraint. So when I change this to 3, you see they all change. Again, this is all simply about effective way of setting everything up and creating these constraints. I also have here this button or this circle is vertically aligned to there. This is just only one way how to do this. To get exactly to the same results, you could use a different method. So this is something that's really important to understand how flexible this system actually is. With this sketch done, the next step is simply, well, we extrude this front plate out. Also here, this front plate extrudes into the body as a new body. Okay. What do I have here? I have 2 dials. So dials and all these things are obviously all pre-made components. And since we would like also to create a rendering, I simply made myself some dummy pieces. So these are just extrusions from the sketch profiles from these 3 rings. Also new body. Very good. Then the next one we have here. These are going to be LED rings. Around the button, there are actually the dials. There are LED lights. For example, if you speak too loud, they will start flashing and give you color information. No, that's actually all pretty easy. How do we build now? Hold on one second. I want to get the body. Was a body. Yeah. How do we now create the buttons that go in there that can rotate? And in a similar way, how we sketched everything in sketch 3 here to create the revolve geometry, revolve sketch, we do exactly the same here. So there we have actually inside the ring. The sketch is a little bit in my way. So here, this is not only a ring, it's actually a cylinder. So the inside. So along where is that axis? Oh, I hit it. So here. So there's that axis. So I created this axis through this face. Again, I went to construct and then axis through cylinder, cone, or torso. Very nice. Construction plane on it, create a sketch on it. Here is that sketch. Let's take a look at it. Also there, you will see it's always a repetitive process. So I wanted to know where's the left and right maximum. So I needed to, while in sketch mode, say intersect with this face or so. And I selected the inside because it gave me the nice width. Then from this line, a line along the Y, along the X, this will be rotated perpendicular to Y or parallel to X, and then this along Y. So horizontal, these are kind of like horizontal vertical constraints or perpendicular. And then the gap is just 1 millimeter. So from the dial to the plastic surface. The end is 5.2 millimeters. Actually, I measured the diameter and then I divided by 2. That gives me then the radius. And because it slightly tapers also from here, so from this point to this line, there is a readout of 11 millimeters divided by 2. And then this point to here, and that is 13.5. Okay, super easy. And then we do a revolve of that object. Also here again, new body, very good. Then there's a little white strip on there, and we want to render that later and don't have to mess with the polygon geometry during a render inside any render program. So I, on this face, created myself a new sketch. There we are. Because this is a ring, it finds the midpoint. You see here, I just created a rectangle, and then I created a line, made the line construction, locked it to the center point of this ring, locked the line to the midpoint, and then I created a dimension between here and the ring, and that again was, you guessed it right, the right-click arctangent version. Okay. With this sketch now, I can actually go ahead and say split face and say this face and this face, please split with this. And then it splits it. So here you see, not in the back, but because I select only these two faces, this is changed. And something like this, I can later give then a different material. So there we are. And now there you see there's a new material. Cool. Okay. So then we have this dial. And let's then do the same stuff what we did here. And of course, we do not do that. Way too much work. We can simply make a copy and paste and align it. Let me show you how easy that is. So I will hide the other body, and then I will go to copy and say copy point to point. I will select this body and this body, create a copy. Thank you. And then make a copy from this center, or I select this ring here, this edge, to the target, this edge. So, or I could go to this ring. It doesn't matter. Rings have, they're all centered. They all have the center point at the same position. And then okay, and that's it. That's the way how then the copy was made and then moved into the correct position. Okay, then the fun continues. We need to do the next dial. Same process. The axis line construction plane, there is the sketch. And I will just quickly hide these parts so they are out of our way. This is now the socket that goes in for the mic to be inserted. There we are. So here's a small element which I found we are intersecting with that surface. And here are the dimensions. So this is flush with the front, 3.25 millimeter, which will give this then a material thickness of 1.25. This has a length of 135 degrees. And then just for a little bit of extra material, 2 millimeters. Okay, very good. And then that thing we simply rotate. There we are. Awesome. Now also there we have another copy. So we use the copy command and then point to point. Then the next style comes in there. Also here. There is the sketch. Go to the top view. You start noticing it's very repetitive. That's a nice thing about modeling in Fusion. Once you know how to build shapes, it's just a matter of time till you have everything plotted out. Here are the two lines we found. We are intersecting 1 millimeter of a distance. Everything is horizontal and vertical. Also here, the dimension divided by 2. Very good. There is the length for this. And then a rotate command. The next step is actually quite fun. Then we will chamfer that edge, very small, just 0.5 millimeter. Then on this face, we will create a sketch, and I will via project this edge or this face into, actually here, this edge I will project in. That's then the way how I got this. And then I will create there a small, really tiny ring, 0.25 millimeters. There you see, and make this one horizontal constraint to there. And the ring is glued onto this line too. Okay, so why did I do this? Well, the next step, pure magic. We will extrude now that profile. Here, let me actually go back. So we do this more live. So I extrude this one a little bit to there. But no, I do not want to start it here. I want to go in a little bit. So I will say offset and 0.75. No, negative. There. You see how now from here, 0.75, it starts doing this. Okay, but actually join the piece. Thank you. Then you can run down till there. So that looks like 10.5. Okay, and I would like 2 millimeters of a distance to the end. So, or maybe just 1 millimeter there. Cool. So that's the way how you can do an extrusion of a profile and make it start somewhere and end somewhere else, then just at the beginning plane. So I did this. Then when you do the circular pattern, Fusion is going to complain a little bit. So let's do this, but it's also an easy click. Just follow, pay attention to the problem you will hear. So here, that piece, axis, this one, let's say 60. What about the 90? Yeah, and there it is. Too many patterns. Instance, consider using optimize or identical. Okay, let's go here, maybe optimize, and then we can type in 200, and it all works pretty fast. Cool. Okay, so that's the way how I did this. 200 pieces, quite a lot, works like a charm. Also here, the same thing, sketch on that face. Same dimensions, like 1 millimeter thickness, and from this edge to here, tangent dimension 7. Very good. Center line to make it centered. And then we split it. Cool. Okay. So pretty much nearly all is modeled. The only thing left is actually our XLR interface. So yeah, you guessed it, same deal. There is the construction plane and the axis. Here is the sketch for it. This one is pretty simple. Let me go to a better view. There. Very basic. So 8 millimeter from the center, 2 millimeter here for the back. This inside is 31 millimeter from the ring. There's also the find intersection edge. Because with this piece, then I was able to do this rotation, very nice. And don't forget, we have actually this other sketch here. I call this front, so I find it easy. I have these holes. I simply extrude them in. I have no idea how deep that thing really is. I'm not going to cut the product apart, but 10 millimeter is fine. And then we round that corner a little bit with a fillet. V and V there, very nice. Okay. So yeah, so we have then actually constructed ourselves a pretty close replication of that interface. And this was quite an exercise in symmetry modeling and making sure everything is nicely lined up and spaced out by using the construction, the constraints. And before we would bring everything over to Blender, one thing I would do is give everything here a little bit of a color. And I'll show you how we can do that. So we go to modify appearance. Fusion also comes with materials. I'm personally not using this really much for rendering. For modeling, yes. For rendering, not really, because the render engine is simply not satisfying what I think we would need to create professional renderings. It is fine for maybe to make quick renderings if you don't have much time and if you don't get paid for it, yeah, but the problem is it looks like a rendering done in Fusion too. It's the same like with Keyshot. It's made just for a particular use case. Anyway, not to be understood as me ranting. This we would like to look like anodized aluminum. Let's go to metal, double click, and aluminum, double click, and look at there. We have anodized, glossy, anodized rough. So we can actually put various materials onto it. Oh, looks actually pretty cool there. And here, for example, I would like this cap to be same here to look like anodized aluminum. So, but I don't want the whole body to be aluminum. Look, I can go to faces and then I say here, glossy, and drag this one just on these tiny faces. You see? This way you can face by face add a material to something. But if the material, for example, if the body has more faces with a black material, like this is actually rubber, then what you want to do is you assign first, let's say we type in rubber and there. Okay, we'll use soft. That whole thing I drag onto this. Yeah, this will remove everything, and that is good. I have actually, where's my here? There, I adjusted the color a little bit. And then to change this, I have an ABS white material, just simply plastic. So that's more like a placeholder. And then I switch to this, drag this one on. I have to rotate my view there. Okay. Very nice. Cool. This is actually plastic. So let's go to plastic, textured random. I drag this one onto it. And we can drag this one onto there. And let me see where's my one there. So when I put this one onto it and then later you double click it, let me zoom in a little bit. There. We have a scale factor. With the scale, you can adjust that pattern a little bit. Okay. Then we zoom in, you see this is a little bit smaller. Okay, so perfect. The materials don't carry over to any render engine, but what it does when I export everything. Oh, by the way, this one is actually just an LED. So if you look for the LED material, that's what I had there. If you export this later via OBJ, then each object comes with the material definition, not the material itself, but for example, these dials will have two materials, and then in the render program, for example in Blender, then we can modify these materials automatically. So we don't have to select the polygon faces and texture them. We can just go ahead and just adjust the materials. That's the beauty behind this process. Very good. The feet also got a soft rubber material, like the dials, so they don't slide. And yeah, this is pretty much it for how to model and then texture it.